Hey there, I'm George Everett, and welcome to Zzzcience, where the noise of the day fades and curiosity drifts softly into sleep. Tonight, we're floating through the restless world above us, the sky, a place where clouds bloom and fade, storms rise and fall, and sunlight dances through oceans of air. What we call weather is really the heartbeat of our planet, alive, breathing, and endlessly changing. So, wherever you are tucked in, winding down, or just letting your thoughts wander, let the quiet rhythm of the atmosphere guide you toward rest. If you enjoy these calm journeys through science and wonder, I'd love for you to subscribe and drift along with me again sometime. But for now, there's nothing you need to do but rest. Settle in, breathe deeply, and allow your mind to wander into the fascinating world of weather. Let's begin. A single storm cloud can weigh more than 1,000,000 elephants. When you look up at a drifting cloud, it seems soft and weightless, almost like cotton pulled across the sky. But the truth is astonishing. A typical cumulus cloud, the kind that floats on a summer afternoon, can hold hundreds of thousands of tons of water. All those droplets, too small to see individually, add up to an unimaginable mass heavier than 1,000,000 elephants standing side by side. And yet the cloud floats, suspended because the water is spread into countless microscopic drops, each carried upward by rising warm air. The sight of something so immense, so heavy, yet appearing delicate and ethereal, is one of the great paradoxes of weather. The next time you tilt your head to watch a cloud drift lazily above you, remember that it carries the weight of entire lakes in its gentle embrace. Lightning is hotter than the surface of the sun. In the blink of an eye, a jagged bolt of lightning splits the sky. It looks like pure white fire, but its true temperature is even more startling. A lightning strike can reach over 30,000 degrees Celsius, making it several times hotter than the surface of the sun. The energy involved is staggering, powerful enough to superheat the air around it, turning it into plasma and igniting the sky with blinding brilliance. That sudden expansion of air is what we hear as thunder rolling across the landscape. Each flash of lightning is like nature's own laboratory experiment, compressing unimaginable heat and energy into a fraction of a second. Some bolts travel miles, connecting sky and ground in a shimmering chain. For all its violence, lightning is also light. It helps fix nitrogen into the soil, feeding the very plants that sustain us. The sound of thunder is air exploding from sudden heat. Thunder rolls low and deep across the sky, sometimes like distant drums, sometimes sharp and startling. What we are really hearing is the voice of lightning. When lightning flashes, it heats the air so quickly and so intensely that the molecules cannot keep up. They expand in a violent rush, creating a shockwave that races outward faster than the speed of sound. That shockwave is thunder. Depending on your distance, the sound may crack, rumble, or echo between hills and buildings. Because light travels much faster than sound, we see the flash long before the noise reaches us, which is why counting seconds between lightning and thunder can reveal how far away the storm is. In this way, thunder is both a warning and a wonder, a reminder of the immense forces at play above us. Wrapped in the rolling rhythm of the storm, raindrops are not teardrop-shaped at all. Children's drawings often show raindrops falling like perfect teardrops, pointed at the top and rounded at the bottom. But in reality, raindrops are nothing like that. The smallest drops are almost perfectly spherical, held together by surface tension. As they grow larger, air resistance flattens their bottoms, giving them a shape more like a hamburger bun than a teardrop. If they grow too big, they can no longer hold together and break apart into smaller droplets. This subtle detail makes rain even more beautiful when you imagine each drop tumbling from the sky in its own perfect form. The illusion of teardrops comes from how falling water looks on windows or cheeks, stretched by gravity as it slides downward. But the raindrops drifting down onto fields, roofs, and rivers carry their own hidden geometry, tiny rounded jewels. Not the sharp shapes we imagine. The smell of rain comes from ancient oils and cosmic particles. There is a word for the earthy, comforting fragrance that rises after a rainstorm. This scent is created by a blend of remarkable ingredients. Tiny plants release oils into dry soil during long stretches without rain. When raindrops strike the ground, they break bubbles in the soil that carry these oils into the air. At the same time, another compound called geosmon, produced by soil-dwelling microbes, fills the air with its rich, earthy perfume. And during storms, lightning can split molecules of oxygen and nitrogen, creating ozone, which adds a sharp, fresh note to the mix. The result is the unmistakable smell of rain, a scent tied to ancient soils, living microbes, and even the chemistry of the sky itself. When you inhale that fragrance, you're breathing in a story as old as Earth and as wide as the atmosphere. Snowflakes can fall at vastly different speeds. We picture snow drifting silently, each flake twirling in slow motion. And while some snowflakes really do float gently, others fall surprisingly fast. The speed depends on their size and structure. Small, delicate crystals may descend at just a tiny fraction of a meter per second, hovering in the air as though reluctant to land. Larger flakes made of many crystals stuck together can tumble down at speeds closer to a few meters per second. Wind currents complicate things further, tossing flakes sideways, upward, and in spirals. In some cases, flakes are carried for miles before they finally reach the ground. So when you see snow falling, you are watching a ballet choreographed by air resistance, gravity, and the hidden architecture of ice. Every descent is unique, a quiet journey through the atmosphere. Before settling into the white hush of winter, some snowflakes are wider than a coin. Most snowflakes are small, delicate crystals, no bigger than a fingernail. But under the right conditions, they can grow to extraordinary sizes. Moist air, gentle winds, and just the right temperature can allow flakes to stick together, forming clusters wider than a coin or even as large as a dinner plate. The biggest snowflakes on record were reported in Montana in the late 1800s, said to be more than 15 inches across. Imagine such immense flakes tumbling slowly from the sky like icy feathers drifting down. While most of us will only ever see flakes the size of coins or smaller, knowing that the sky can produce such giants adds a touch of magic to winter storms. Each flake, no matter how large or small, carries within it the complex geometry of ice crystals grown in silence high above the earth. Blizzards can make it impossible to see your own hand. A blizzard is not just a heavy snowfall. It is a storm where wind and snow combine into a blinding wall. In the midst of one, visibility can drop to just a few feet. Travelers caught in such conditions sometimes describe being unable to see their own hands held out in front of them. The snow is whipped into the air by powerful gusts, creating a swirling whiteout where all sense of direction vanishes. Temperatures plummet, and wind chills can freeze exposed skin in minutes. To those living on open plains or high mountains, blizzards are among the most dangerous weather events, capable of disorienting even experienced explorers. And yet, within the storm's ferocity, there is also a strange beauty, the transformation of the world. into a blank canvas of white where silence and chaos exist at the same time. Hailstones can grow in perfect layers like onions. When a thunderstorm's updraft is strong enough, raindrops are carried high into the colder layers of the cloud where they freeze into tiny pellets of ice. These pellets may then fall back down, gather more water, and be lifted again, freezing layer upon layer in the process. By the time they finally fall to earth, hailstones may carry dozens of concentric rings, like the growth rings of a tree or the layers of an onion. Sliced open, they reveal their hidden history, each layer a record of a journey through the storm. Small hailstones may be harmless, but larger ones can shatter windows, flatten crops, and dent cars. The largest can weigh more than a pound. Even so, they are natural sculptures carved by the turbulent breath of clouds, carrying the memory of the storm in their icy design. The largest hail ever recorded was bigger than a volleyball. In July 2010, in the small town of Vivian, South Dakota, an astonishing piece of hail fell from the sky. It was nearly the size of a volleyball, inches across and weighing almost 2 pounds. Imagine such a sphere of ice hurtling toward the ground at high speed. Fortunately, it landed in a field rather than striking a home or person, but it remains the largest hailstone ever measured in the United States. Around the world, storms have produced other enormous hailstones, each formed by powerful updrafts that carried them up and down inside storm clouds, layering ice upon ice. Most hailstones are no larger than peas, but records like Vivian's remind us of nature's extremes. The sky, under rare conditions, can produce ice missiles of terrifying size sculpted by turbulence, then hurled back down to earth. Tornado winds can fling straw through solid wood. Tornadoes are among nature's most astonishing forces, twisting across the land with winds so strong they can turn the ordinary into the unthinkable. One of the strangest pieces of tornado lore is also true. Lightweight straw, in the grip of a tornado, can be driven straight through solid wood. The winds accelerate debris to such extraordinary speeds that even the gentlest objects become piercing projectiles. Pieces of straw have been found embedded in fence posts, utility poles, and even the walls of houses after a storm. It's a reminder of just how violent the air can become when it spins into a vortex. The tornado doesn't need heavy weapons, can turn grass into arrows. To stand in the path of such a storm would be to face a force that bends the rules of everyday reality, where fragile things become instruments of destruction. The fastest tornado winds rival the speed of a jet plane. When we think of powerful winds, we may picture hurricanes or strong storms at sea, but tornadoes leave even those in the dust. The most intense tornadoes, called EF5 South on the enhanced Fujita scale, have winds measured at more than 300 miles per hour, comparable to the cruising speed of a passenger jet. In such winds, cars can be tossed into the air like toys, steel beams can twist, and entire buildings can vanish from their foundations. Storm chasers who have survived close encounters describe the roar of these winds as sounding like a freight train bearing down unstoppable and immense. Thankfully, tornadoes of such intensity are rare, but knowing they exist is enough to inspire awe. They are the planet's most concentrated bursts of atmospheric fury, a reminder that the air around us can sometimes move with unimaginable speed. Hurricanes release more energy than every power plant on Earth combined. A hurricane is a storm on a scale that almost defies comprehension. Spanning hundreds of miles and fueled by warm ocean waters, it gathers moisture and heat, building into a vast spinning engine. The energy released in a single day by a mature hurricane is greater than the energy used by all of humanity's power plants combined. Imagine every coal plant, every nuclear reactor, every wind turbine, and solar panel feeding electricity into one grid and still falling short of the output of a single storm. Most of this energy is released as heat carried away by the condensation of billions of raindrops, while the rest is unleashed as fierce winds and pounding waves. To stand near a hurricane's edge is to feel just the faintest brush of its power, while satellites from space can only capture its swirling immensity. It is Earth's most spectacular weather machine. The calmest part of a hurricane is at its violent center. Step into the eye of a hurricane, and you will find something almost unbelievable. After hours of howling winds and torrential rain, a sudden silence falls. The air clears, the clouds part, and sometimes the sun even shines. This is the eye, a circular region at the heart of the storm, often 20 to 40 miles wide. Here, the winds calm and the sea surface steadies, but it is not a place of safety. Surrounding the eye is the eye wall, a towering ring of thunderstorms where the storm's winds reach their absolute peak. The eye is like the still heart of a spinning wheel, calm only because the chaos rages so fiercely around it. For those who have experienced it, the eye is eerie, peaceful, beautiful, and filled with dread, because they know that after a brief pause, the storm will return with full force. Monsoons can transform entire landscapes in a single season. In many parts of the world, life is tied to the rhythm of the monsoon. These are seasonal winds that shift direction, bringing with them immense rains. For months, parched lands may lie dry and cracked, waiting for relief. Then, almost overnight, the skies open. Rivers swell, fields flood, and forests come alive with green. The monsoon rains are both life-giving and destructive. They water crops that feed hundreds of millions, but they can also unleash floods and landslides that reshape the land. In India, Southeast Asia, and parts of Africa, whole cultures and histories have grown in harmony with the cycle of the monsoon. Farmers plant and harvest according to its timing. Festivals celebrate its arrival. To witness a monsoon is to see weather on a continental scale, turning of the atmosphere so vast it changes the face of nations. The Atacama Desert can go decades without a drop of rain. There are dry places, and then there is the Atacama. Stretching across northern Chile, it is considered the driest non-polar desert on Earth. Some weather stations in the Atacama have never recorded a single drop of rain, and parts of it may go decades without measurable precipitation. The soil is so barren that NASA has studied it as an analog for Mars, yet even here, life finds a way. Certain plants draw water from fog drifting in from the coast, while microscopic organisms cling to existence deep in the ground. On rare occasions when rain does fall, the desert explodes into color. Wildflowers bloom across the sands in a spectacle called the Deserto Florido. To stand in the Atacama is to feel the silence of a place almost untouched by weather, where the sky is vast and every drop of water is a miracle. The wettest place on Earth is soaked by walls of rain. In northeastern India lies the village of often called the wettest inhabited place on Earth. Each year, monsoon winds from the Bay of Bengal funnel into the surrounding hills, forcing moist air upward. The result is astonishing, an average rainfall of nearly 12 meters per year. Imagine rain so heavy that rivers roar down streets, waterfalls surge from cliffs, and the sound of water is a constant companion. Roofs are built of sturdy materials to withstand the deluge, and villagers even weave living root bridges to cross the swollen streams. Life here is shaped entirely by rain. While most people measure precipitation in inches or centimeters, in Mosinram it is measured in towering walls of water that return every year without fail. It is a reminder that weather is not evenly spread. Some places drown in rain, while others thirst endlessly. The hottest temperature ever recorded could melt car tires. In July of 1913, in Death Valley, California, a furnace-like wind swept across the desert floor. The official temperature measured was 56.7 degrees Celsius, or 134 degrees Fahrenheit, the hottest ever reliably recorded on Earth. At such heat, asphalt softens, metal sears to the touch, and car tires risk melting if driven too long. The human body struggles to shed warmth, and even in the shade, survival becomes difficult without water. Death Valley earned its name from such extremes, where daytime heat rises off the rocks in shimmering waves. Though other places like Kuwait or Iran have come close, Death Valley still holds the crown. The fact that such temperatures exist on our own planet is a stark reminder of the atmosphere's power. The air above us is not just mild and gentle. It can become a blazing, deadly furnace. The coldest air on Earth can freeze metal in seconds. At the heart of Antarctica, on a high plateau far from the sea, lies a place where the air itself feels alien. Here, in 1983, at Vostok Station, scientists recorded a temperature of -89.2 degrees Celsius, colder than dry ice, cold enough to make steel brittle and shatter glass. More recently, satellites have measured even lower readings in nearby hollows, approaching -98 degrees. In such conditions, breath freezes into crystals, machinery locks up, and exposed skin can freeze solid almost instantly. This is colder than the average surface of Mars. To live here requires extraordinary preparation: heated shelters, insulated suits, and constant vigilance. Yet even in this frozen heart of Earth, weather still moves. Winds howl, snow drifts, and clouds pass slowly overhead. It is the ultimate frontier of cold, where Earth's atmosphere meets its most extreme silence. Heat waves kill more people than any other type of extreme weather. Storms and floods often make headlines, their power visible and dramatic. But the deadliest form of weather is far quieter: the heat wave. When air grows still and temperatures soar for days or weeks, the human body begins to struggle. Without relief, heat stress builds, straining hearts and dehydrating tissues. Cities suffer most, where asphalt and concrete absorb heat, creating islands of stifling air. Nights offer little respite as buildings release the warmth stored during the day. Around the world, heat waves have claimed tens of thousands of lives, often silently, affecting the elderly, the very young, and those without shelter. Unlike a storm, you may not see its violence, but it is there in rising hospital admissions, in fields of withered crops, in overheated rivers where fish die by the thousands. Heat waves are weather's most insidious threat, creeping in quietly but with devastating power. Fog can be so thick you can't see your own feet. Fog is one of weather's quietest tricks: a cloud lowered to the ground, wrapping the world in pale silence. Usually, it makes the horizon vanish, blurring buildings and trees into ghostly shapes. But in rare cases, fog can become so dense that visibility shrinks to just a few feet, and people walking through it describe being unable to see their own feet clearly. In this kind of fog, sound behaves strangely too, muffled and close, as though the air itself is thick. Airplanes are grounded, ships slow to a crawl, and drivers are forced to inch forward in eerie caution. Despite its softness, fog can be one of the most dangerous weather events. And yet, to walk through it can feel otherworldly, like moving inside a dream where the edges of reality have dissolved, leaving only whiteness and the sound of your own breath. Dew can collect enough water to sustain life in deserts. In the dry silence of deserts, rain is often a rarity, but dew is a quiet savior. As the sun sets, the ground cools quickly, and if the air temperature dips below a certain point, moisture condenses onto rocks, leaves, and even grains of sand. Each morning, the desert wakes adorned with tiny beads of water. For plants and animals that have evolved to survive here, this dew can mean the difference between life and death. Beetles tilt their bodies to catch droplets that slide into their mouths. Certain plants channel dew down their stems toward thirsty roots. Even humans have learned to harvest it using nets or surfaces designed to collect these shimmering jewels of water. Though each droplet is small, together they provide sustenance in places where rain may not fall for months. Dew is desert rain delivered in whispers instead of storms. Frost crystals can grow into spiky forests of ice. On winter mornings, frost sometimes paints delicate patterns on windows' curling leaves, fern-like tendrils, shimmering lace. These are ice crystals forming as water vapor freezes directly onto a cold surface. But in the right conditions, frost can grow into something much larger and stranger. On mountain peaks and polar plateaus, frost can form spiky forests of ice known as hoarfrost. Here, the crystals stretch upward into jagged towers, sometimes inches long, catching the morning light like glass sculptures. Each spike grows as vapor condenses onto its surface, layer upon layer, until the whole landscape bristles with frozen blades. In the stillness of cold air, they remain fragile, crystalline, and sharp. Step too close, and they crumble at the touch. Yet for as long as they last, they transform the ordinary world into something otherworldly, a forest of ice, born from nothing more than cold air and breath. Ice storms coat cities in a dangerous glassy shell. There is beauty in an ice storm, but it is the kind of beauty edged with danger. When rain falls through a layer of freezing air close to the ground, the drops turn to supercooled liquid, still liquid as they fall, but ready to freeze the instant they touch a surface. Roads glaze into sheets of invisible ice. Tree branches turn into crystal sculptures, and power lines sag under their sudden weight. At night, headlights catch the frozen world in shimmering reflections, every twig and blade of grass encased in glass. But beneath this brilliance lies danger. Roads become impassable, trees snap, and whole neighborhoods may lose power for days. To walk outside during an ice storm is to move through a fragile world of frozen jewels where every surface is slick and treacherous. It is weather at its most deceptive, breathtaking, but perilous. Dust devils can rise taller than skyscrapers. On a hot, dry afternoon, the ground can heat unevenly, sending columns of warm air spiraling upward. Sometimes this air begins to spin, forming a dust devil. Many are small, swirling just a few feet across, but some grow to astonishing heights, twisting towers of dust rising taller than skyscrapers. Unlike tornadoes, dust devils form under clear skies, dancing across deserts, fields, and even parking lots. Harmless ones flick leaves and sand, but the largest can topple fences, lift roofs, or hurl debris across the ground. Pilots have reported seeing massive dust devils from the air, towering over the land like temporary giants. They are brief, chaotic, mesmerizing miniature whirlwinds that reveal how alive the atmosphere is. even on days that appear calm. To watch one is to see the invisible currents of heat and air made. Suddenly and dramatically visible, waterspouts can spin across the ocean like watery tornadoes. Imagine standing on a shoreline and seeing a slender, twisting column rise from the sea, stretching up to the clouds above. This is a waterspout, a vortex of air and mist, shaped like a tornado but formed over water. Some are relatively weak, spinning harmlessly across bays or lakes before vanishing. Others are powerful enough to toss boats, snap masts, and whip waves into a frenzy. Fishermen have long told stories of waterspouts looming like ghostly funnels on the horizon. From a distance, they can be strangely beautiful, spirals of silver mist gliding across the sea, lit by sunlight or lightning. But up close, they are forces of chaos, blending storm winds with ocean spray. Waterspouts are reminders that tornado-like fury is not confined to land. Even the calm open sea can suddenly twist into a whirling tower of water reaching for the sky. Microbursts can slam planes out of the sky. Microbursts are among the most dangerous and least visible threats in weather. They occur when a thunderstorm suddenly dumps a mass of cool air that plunges toward the ground and spreads outward at high speed. To those on the ground, a microburst may feel like a sudden violent blast of wind knocking down trees or flattening fields. But for airplanes, the danger is far greater. A plane flying into a microburst may suddenly lose lift, forced downward faster than the pilot can react. Several accidents in the past revealed their deadly potential, leading to new safety systems that detect them. Microbursts are short-lived, sometimes lasting only minutes, but their power is immense, with winds exceeding 100 miles per hour. Invisible until they strike, they show how storms can unleash fury not just in lightning and rain, but in sudden catastrophic blasts of air. Supercell storms can grow larger than entire states. Most thunderstorms are small, localized events lasting less than an hour, but supercells are different. They are massive, organized storms with rotating updrafts that can last for many hours. On satellite images, they can stretch across hundreds of miles, sometimes larger than entire US states, within their towering clouds, which can rise more than 10 miles into the sky. Whole weather systems come to life, lightning flashing thousands of times per minute, hailstones forming layer upon layer, tornadoes spinning giddily into existence. Supercells are rare, but they are the engines of the most destructive weather on Earth. To watch one forming from a distance is to see the atmosphere. Flex its muscles, a dark rolling wall of cloud so vast it reshapes the horizon itself. They are storms that seem alive, breathing, rotating, and growing until the land beneath them feels small. Some thunderstorms can last for more than 12 hours. We often think of thunderstorms as fleeting, a quick burst of lightning, a downpour, and then clearing skies. But under the right conditions, thunderstorms can endure far longer. Systems called mesoscale convective complexes can persist for 12 hours or more, traveling across entire regions while maintaining their intensity. Within them, waves of storms rise and collapse in a self-sustaining cycle, feeding on warm, moist air and releasing torrents of rain. These long-lived thunderstorms can cause widespread flooding, lightning outbreaks, and powerful winds. From above, they appear as sprawling masses of cloud glowing with flickering lightning, like a living organism. For those beneath them, the storm becomes a companion through the night, never-ending rumbles, repeated flashes, rain that seems endless. They remind us that weather is not always a brief event. Sometimes the sky itself settles in for a long and restless stay. There is a storm in Venezuela that has produced lightning for centuries. Over the mouth of the Catatumbo River in Venezuela, a storm has been raging for centuries. Known as the Catatumbo lightning, it is a natural phenomenon where lightning storms occur almost nightly, sometimes for 10 hours at a time, for more than 200 nights each year. The unique geography of the region, warm winds from the Caribbean colliding with cold air from the Andes, creates a perfect recipe for constant storms. From miles away, the sky above Lake Maracaibo glows with flickering light, a silent fireworks display seen even by sailors far out at sea. For generations, people have called it the Lighthouse of Maracaibo, a beacon visible without end. Scientists are still studying why this location is so uniquely but one thing is certain: nowhere else on Earth does lightning pulse with such relentless, timeless rhythm. Weather balloons can rise higher than Mount Everest. Every day, hundreds of weather balloons are released around the world, carrying instruments called radiosondes into the sky. They look simpler, just large balloons filled with helium or hydrogen, yet they climb to extraordinary heights. Rising at about 1,000 feet per minute, they drift far above airplanes, far above clouds, into the stratosphere itself. By the time they burst, they may be over 20 miles high, soaring much higher than Mount Everest. At those altitudes, the air is so thin and cold that temperatures plunge to -90 degrees Celsius, and the horizon curves against the black of space. As they rise, these balloons measure temperature, pressure, humidity, and wind, sending back data that allows us to forecast the weather days ahead. Though unseen by most of us, they are explorers of the atmosphere, silent travelers that map the invisible ocean of air surrounding our planet. Satellites can see hurricanes from space in real time. Orbiting hundreds of miles above Earth, weather satellites watch over us like silent guardians. When hurricanes form over the oceans, satellites capture their spiral arms stretching across hundreds of miles. Their eyes open like immense pupils staring upward. From space, a hurricane is breathtakingly beautiful, a swirling geometry of clouds endlessly rotating. But within those graceful patterns lies devastating power. Modern satellites can track these storms in real time, mapping rainfall, measuring wind speeds, and even peering inside with infrared sensors to watch the heat signatures of clouds. This constant vigilance saves lives, giving coastal cities precious hours or days to prepare. Before satellites, storms would strike with far less warning. But now we can watch them grow, travel, and eventually fade back into the sea. From the cold silence of orbit, satellites see Earth's most violent storms not as chaos, but as mesmerizing living patterns. Doppler radar can track raindrops moving through the air. When a storm approaches, the familiar green and red patterns on weather maps are made possible by radar. But modern Doppler radar does far more than simply detect rain. By bouncing radio waves off raindrops and snowflakes, it can measure not only their location, but also their speed and direction. This allows meteorologists to see inside storms in astonishing detail, tracking rotation that might spawn tornadoes, or spotting bands of heavy rain that could lead to flooding. In effect, Doppler radar turns the invisible movements of the atmosphere into a visible map, a portrait of swirling chaos. Translated into color, each pixel of red, green, or purple represents countless droplets tumbling through the sky. For those who know how to read it, Doppler images are like fingerprints of storms, revealing their hidden structure and letting us glimpse the choreography of weather as it unfolds. Above our heads, the northern lights are a form of space weather. high above the polar regions. Shimmering curtains of green, purple, and red dance across the night sky. These are the northern lights, or aurora borealis. And though they look like earthly weather, their origin is cosmic. Streams of charged particles from the sun collide with Earth's magnetic field, funneled down toward the poles. When they strike atoms in the upper atmosphere, they excite them, causing them to glow. What we see as shifting ribbons of light is the atmosphere itself coming alive. This is not just weather of the Earth, but space weather, reminder that our atmosphere is a shield against the sun's constant stream of energy. Watching the aurora is like witnessing Earth's magnetic heartbeat, a direct link between solar storms and the fragile veil of gases that protect our world. It is cosmic poetry written in light across the sky. Solar storms can disrupt Earth's weather systems. When the sun erupts with a solar storm, clouds of plasma and magnetic energy stream across space at astonishing speeds. These storms can strike Earth in just a couple of days, rattling our magnetic field and sparking brilliant auroras. But they can also reach deeper, disrupting satellites, power grids, and even atmospheric circulation. Some scientists believe strong solar storms may temporarily influence weather on Earth by altering the way the atmosphere absorbs energy. These connections are subtle and not fully understood, but they remind us that Earth's weather is not sealed off from space. We live within the sun's extended reach, our atmosphere constantly stirred by its invisible hand. Even when skies are clear, solar storms can ripple through the fabric of our environment. In this sense, Earth's weather is never entirely on it, is part of a larger conversation with the star that sustains us. Even jet contrails can change local cloud cover. Look up on a clear day, and you may see the long, thin trails left by airplanes crisscrossing the sky. These contrails, formed from exhaust mixing with cold, moist air, can linger and spread, merging into thin cirrus clouds. Though they seem delicate, contrails can alter local weather by changing how sunlight and heat move through the atmosphere. In some regions, widespread air traffic has been shown to increase cloud cover noticeably, subtly warming nights and cooling days. After the September 11th attacks in 2001, when flights were temporarily grounded in the United States, scientists observed unusual swings in day and night temperatures, hint of how much contrails normally influence the balance. It is a reminder that even small streaks of human activity can ripple outward into the great ocean of weather, painting the sky and shifting the planet's breath in ways we seldom notice. Flash floods can move boulders the size of cars. Water is usually gentle, carving valleys over centuries and wearing down mountains grain by grain. But in a flash flood, water shows its other face, sudden, furious, unstoppable. When torrential rain falls in a short time, rivers can swell in minutes, and dry gullies can become roaring torrents. These walls of water carry with them sand, branches, and even boulders weighing tons. Entire cars can be lifted and swept away. Streets turn into rivers, bridges crumble, and landscapes are rearranged overnight. Flash floods are especially dangerous because they arrive with little warning, often under skies that seem deceptively calm just upstream. For those caught in their path, the power of moving water is unforgettable. It is the voice of gravity magnified by storm, reminding us that weather can turn the softest element, water, into one of Earth's most devastating forces. Some droughts have lasted for hundreds of years. When the rains fail, the world changes slowly but profoundly. Crops wither, rivers shrink, and soils crack. Most droughts last for months or years, but in the geological past, some have stretched for centuries. These megadroughts have left scars in tree rings, lake beds, and even the ruins of vanished civilizations. In North America, evidence shows that the western United States endured droughts, lasting hundreds of years during the medieval period, far longer than anything seen today. Such droughts reshape entire regions, transforming forests into grasslands and grasslands into deserts. People are forced to migrate, abandon settlements, or adapt in extraordinary ways. Drought is a silent kind of weather. No storms, no thunder, no spectacle, just an absence stretching on and on until landscapes and histories bend beneath it. In its quiet way, a drought can be every bit as powerful as a hurricane or a flood. El Niño can shift weather across the entire planet. Every few years, the Pacific Ocean warms in a phenomenon called El Niño, and when it does, the atmosphere responds. Winds shift, currents change, and weather patterns ripple outward across the globe. South America sees torrential rains, while parts of Asia endure drought. Hurricanes, monsoons, and even winter storms in North America can all be altered by the pulse of El Niño. What begins as a change in ocean temperature near the equator cascades into consequences felt thousands of miles away. It is one of the clearest demonstrations of how interconnected Earth's systems are: the ocean and the atmosphere moving in rhythm, touching weather on every continent. For farmers, fishermen, and scientists, El Niño is both a challenge and a mystery, a reminder that the heartbeat of the planet's climate is set not by one place alone, but by the vast ocean currents beneath the sky. La Niña brings the opposite effect in cooling winds. After El Niño often comes its opposite, La Niña. During these periods, the Pacific Ocean's surface cools, and the winds that sweep across it strengthen. The effects are just as global, but reversed. Drought may strike where rains once poured, hurricanes may form in new regions, and winters in some parts of the world grow harsher. La Niña is part of a natural, circular swinging pendulum of heat and cold in the equatorial Pacific that resonates through the whole atmosphere. Though invisible to the eye, these shifts are powerful enough to alter rainfall in Africa, typhoons in Asia, and storm tracks across North America. To think that the cooling of ocean waters in one part of the globe can steer whether thousands of miles away is to glimpse the planet's deep interconnectedness, an Earth whose weather is truly one great system. Ocean currents act like giant rivers of heat. Beneath the ocean surface flow currents so vast and steady that they resemble hidden rivers. Unlike rivers of fresh water, these currents are driven by temperature, winds, and the rotation of the Earth. They transport enormous amounts of heat around the globe, redistributing the sun's energy and balancing the climate. Warm water from the equator drifts toward the poles, while colder water sinks and slides back toward the tropics. Without these invisible rivers, much of Earth would be uninhabitable, with sweltering equatorial zones and frozen mid. Instead, currents act as Earth's hidden thermostat, moderating extremes. From space, the swirling gyres they form look like spirals of living art, vast enough to cover entire oceans. To stand on a shore and feel a warm current brushing past your feet is to touch the edge of a system that ties continents together. An endless flow linking all weather. The Gulf Stream helps keep Europe warm in winter. Europe lies far north, on the same latitude as Canada, yet winters there are much milder. The reason flows across the Atlantic Ocean, the Gulf Stream. This powerful current carries warm water from the Gulf of Mexico northeastward, releasing its heat into the air as it travels. By the time it reaches Europe, the air above it is warmer than it otherwise would be, softening the chill of winter. Without the Gulf Stream, much of northern Europe would face climates closer to Siberia, with harsher winters and shorter growing seasons. Farmers, cities, and entire cultures are shaped by this steady river of warmth. Scientists continue to watch it closely because shifts in the Gulf Stream could have dramatic impacts worldwide. For now, though, it remains one of Earth's most important lifelines, conveyor of heat, a hidden partner in the dance of weather and climate. The polar vortex can push Arctic cold into the south. Far above the North Pole swirls a mass of icy air known as the polar vortex. Normally, this frigid circulation is trapped high in the atmosphere, contained by strong winds. But sometimes it weakens and wobbles, spilling Arctic cold southward. When this happens, regions far from the poles, places like the American Midwest or Central Europe, suddenly find themselves in the grip of extreme cold, with temperatures plunging to dangerous levels. These outbreaks can freeze rivers, paralyze cities, and shatter records. The term polar vortex has become familiar in news headlines, but the phenomenon is not new. It is part of the natural rhythm of Earth's atmosphere, a reminder that the Arctic is not sealed away but connected to us all. The next time icy air sweeps unexpectedly across your city, you may be feeling the edge of that vast spinning crown of cold. A volcanic eruption can change weather worldwide. When a volcano erupts with immense force, its effects can be felt far beyond the mountain itself. Explosive eruptions blast ash and gases high into the stratosphere, where winds spread them around the globe. Tiny particles of sulfur dioxide can linger for months or even years, reflecting sunlight and cooling the planet. The eruption of Mount Tambora in 1815 caused what became known as the Year Without a Summer, bringing frost and famine across the northern hemisphere. Crops failed, rivers froze in midsummer, and skies turned hazy with ash. More recently, the eruption of Mount Pinatubo in 1991 lowered global temperatures for several years. Volcanic eruptions are a stark reminder of how tightly linked Earth's systems are. Mountains' fury can alter the balance of sunlight and air worldwide. In weather, even the fire of the Earth itself has a voice, whispering through the clouds and storms. Forest fires can create their own lightning. When a forest burns with intense heat, flames can rise hundreds of feet into the air. The heat drives powerful updrafts, lifting ash and smoke into the sky. Inside these clouds, particles collide and generate static electricity, much like in a thunderstorm. The result is pyrocumulus clouds, storm clouds born from fire that can unleash their own lightning bolts back down onto the burning forest. These lightning strikes may ignite new fires, creating a cycle of flame feeding on itself. Firefighters sometimes witness skies flashing with lightning even as flames roar below, eerie union of fire and storm. This phenomenon shows that weather is not only a force upon landscapes, but also a force created by them. A burning forest becomes a temporary weather system, alive with thunder and fire. An intense reminder of nature's power to amplify itself in extraordinary ways. Smoke from fires can seed strange new clouds. When vast wildfires send smoke plumes high into the sky, they do more than darken the horizon. The tiny particles within smoke can act as nuclei around which water vapor condenses, forming clouds. Sometimes these clouds grow thick enough to cast wide shadows across the land, altering temperatures below. In extreme cases, smoke-driven clouds climb into the stratosphere, traveling thousands of miles. There, they may linger for weeks, subtly shifting weather patterns far from the original fire. The sight is haunting clouds with unusual hues, tinted orange or grey, glowing red in sunlight. Pilots have reported flying through smoky skies so dense it feels like twilight at midday. These clouds are born not from the sea or sky, but from the flames of Earth itself, proof that fire and weather are intertwined, each capable of creating and shaping the other in unexpected ways. Dust from the Sahara Desert travels all the way to the Amazon. Every year, winds lift millions of tons of fine dust from the Sahara Desert, carrying it high into the atmosphere. These dust clouds cross the Atlantic Ocean, sometimes visible in satellite images as golden veils stretching for thousands of miles. Eventually, much of this dust falls onto the Amazon rainforest, where it delivers essential nutrients, particularly phosphorus, that enrich the soil. Without this transoceanic journey, parts of the Amazon might struggle to sustain its incredible biodiversity. The idea that one of the driest places on Earth helps feed one of the wettest and most lush is a powerful reminder of planetary interconnectedness. Even the air is a conveyor belt, linking desert and jungle in an unseen exchange. When you breathe in air touched by distant lands, you may be inhaling the fine dust of ancient dunes, carried across oceans to sustain life in another hemisphere. Hurricanes can churn the sea until it glows with plankton light. Hurricanes are famous for their destructive winds and rain, but beneath the waves they stir another wonder. As the massive storm churns the ocean, it stirs plankton, microscopic organisms that sometimes glow when disturbed. Sailors have reported sailing through seas illuminated with a ghostly blue light during storms, the surface glowing as though alive. This bioluminescence is created by chemical reactions inside the plankton, a defense mechanism triggered by turbulence. Though invisible from satellites, for those who witness it, the sight is unforgettable. A hurricane, not only roaring above, but painting the sea with light below. These glowing oceans remind us that weather touches every layer of the planet, from the atmosphere to the deepest waters. Even in destruction, storms create moments of strange. Weather helps carve mountains into valleys. Mountains may seem eternal, but weather is always working to reshape them. Rain seeps into cracks, freezing and thawing, breaking rock apart. Wind scours exposed cliffs, carrying away grains of sand. Rivers slice into the slopes, cutting deep valleys and canyons. Over millions of years, even the mightiest peaks are worn down, their sharp edges softened, their summits lowered. The Himalayas and Rockies are still rising from tectonic forces, but weather battles them with relentless patience. Every landslide, every rockfall, every rushing stream is part of the quiet chiseling of the atmosphere. Without weather's erosion, Earth would be a harsher, sharper place. Instead, it is weather that sculpts the rounded hills, fertile valleys, and winding rivers we know. When you stand in a canyon or gaze at a mountain's worn face, you are seeing weather's artwork etched in stone across the ages. Wind can sculpt stone into arches and spires. In deserts around the world, strange shapes rise from the ground, arches, spires, and mushroom-like rocks that seem almost alien. These are the sculptures of wind. Carrying sand like a natural sandblaster, the wind carves into rock over centuries, eroding soft layers while leaving harder ones behind. Some formations stand like towering pillars, others curve into perfect arches framing the sky. Monument Valley in the United States, the stone arches of Utah, and the wind-sculpted pinnacles of the Sahara are all products of this ceaseless work. Though the wind may feel gentle on your skin, Over time, it has the strength to carve landscapes that seem designed by an artist's hand. To walk among these formations is to wander through a gallery of natural sculptures, shaped not by chisels, but by invisible currents of air moving grain by grain across stone. Lightning strikes can turn sand into glass. When lightning hits sandy soil, its immense heat can melt grains of quartz into glass. The strike fuses the sand into hollow branching structures called fulgurites, which resemble frozen lightning in solid form. These fragile tubes can stretch for several feet underground, their surfaces rippled and glossy from molten minerals. Each one is a record of a single lightning striker, signature of fire etched into the earth. Fulgurites are rare treasures for collectors and geologists. Each piece a natural sculpture born in an instant of ferocious energy. Holding one is like holding a fossil of lightning, proof that the sky can transform stone in the blink of an eye. The next time you see lightning fork across the sky, imagine that beneath the ground it may be leaving behind glassy tunnels, reminders of the storm's brief but extraordinary touch upon the earth. Glaciers move like rivers of ice, reshaping continents. To the eye, glaciers seem motionless frozen rivers stretching through valleys, but they are always moving, flowing at speeds that can range from a few centimeters to several meters per day. Over centuries, their slow but relentless motion carves landscapes on a colossal scale. They grind mountains into U-shaped valleys, drag boulders for miles, and polish rock into smooth plains. During the last ice age, glaciers covered much of North America and Europe, reshaping entire continents as they advanced and retreated. Today, their remnants remain in Greenland, Antarctica, and high mountain ranges, still sculpting the land. To stand near one is to feel the weight of time itself, a river not of water but of solid ice, moving with patient strength. Glaciers are living landscapes, slow, unstoppable, and transformative, whispering of ancient winters and the power of weather frozen into motion. Avalanches can move faster than cars on a highway. High in snowy mountains, a fragile balance often exists between slope and snow. When that balance breaks, an avalanche can begin. What starts as a small slide quickly accelerates, gathering snow, ice, and debris into a roaring torrent. Avalanches can reach speeds of over 80 miles per hour, faster than cars on a highway, and with the crushing power to sweep away forests, buildings, and roads. The sound is like thunder rolling down a mountainside, unstoppable once begun. For skiers and climbers, avalanches are a constant danger, triggered by weather, weight, or even a single footstep. Yet they are also part of the mountain's natural cycle, redistributing snow, shaping slopes, and feeding valleys below. Watching one from a safe distance is to witness nature's sudden fury, reminder that snow is not always gentle, but can transform into a surging river of destruction in seconds. Icebergs hide nearly 90% of their mass underwater. The phrase "tip of the iceberg" comes from a striking truth. What we see above the surface is only a fraction of what lies below. Icebergs broken from glaciers or ice shelves float in the ocean, with most of their bulk hidden beneath the waves. Only about 10% is visible, while the rest lurks underwater, vast and invisible. This hidden mass makes icebergs dangerous for ships, as the Titanic tragedy proved. Some icebergs are small, but others are massive, taller than skyscrapers and stretching miles in length. As they drift, they release fresh water into the sea, subtly altering ocean currents and ecosystems. The idea that something so immense can float silently, mostly unseen, captures the imagination. icebergs are monuments of frozen time, slowly melting into the ocean, their true size revealed only to the deep waters that cradle them. Permafrost locks away ancient life forms. In the frozen soils of the Arctic and Siberia lies permafrost ground that has remained frozen for thousands of years. Trapped within it are seeds, microbes, and even the remains of long-extinct animals like mammoths. As long as the permafrost stays frozen, these remnants remain preserved, sealed away in Earth's freezer. But when it thaws, ancient secrets awaken. Scientists have revived seeds tens of thousands of years old, and even microbes that have been dormant for millennia. Thawing permafrost also releases methane and carbon dioxide gases that can affect global climate. To touch permafrost is to touch time itself, a layer of soil that bridges the living present and the frozen past. Beneath your feet may lie not just ice and dirt, but echoes of worlds long gone, locked away until weather and warming air decide to release them once more. Glacial meltwater can create rivers that roar under the ice. Though glaciers seem solid and silent, they are riddled with hidden rivers. As the sun warms their surfaces, meltwater seeps into cracks and tunnels, plunging deep into the ice. There it gathers into roaring streams that carve channels beneath the glacier, echoing like subterranean thunder. These rivers can grow powerful enough to lift the glacier itself slightly off the ground, lubricating its movement. Sometimes, meltwater bursts suddenly from beneath, flooding valleys in what are called JCO Clopes glacial outburst floods. To walk on a glacier unaware of the torrents rushing just beneath is to stand atop a living, breathing system, one where water and ice are constantly in conversation. These hidden rivers remind us that glaciers are not inert blocks, but dynamic landscapes alive, with the pulse of weather and water flowing unseen beneath the frozen surface. Rainbows are full circles, not just arcs. From the ground, we usually see a rainbow as a graceful arc hanging in the sky, its colors stretching from red to violet. But if you could rise high enough, perhaps, in an airplane you would see that a rainbow is not an arc at all, but a full circle of light. The ground simply blocks the lower half from view. Rainbows form when sunlight enters, raindrops, bends, reflects inside, and then refracts again as it leaves, separating the light into its component colors. Every drop creates its own miniature rainbow, and what we see is the collective result of millions of them. No two people ever see exactly the same rainbow, because the angles depend on the viewer's position. It is a personal miracle of light, different for everyone, fleeting, and yet endlessly perfect. Double rainbows reveal a reversed world. Sometimes, after a storm, a second fainter rainbow appears above the first. This happens when sunlight bounces twice inside each raindrop before emerging. The extra reflection reverses the order of colors. So the outer rainbow's red band appears on the inside instead of the outside. Between the two bows lies a darker region called Alexander's band, where less light reaches the eye. Double rainbows feel like echoes, one strong, one faint, together forming a gateway of color across the sky. Ancient cultures saw them as signs of transformation, bridges between worlds. Even knowing the science, the sight remains magical. Light divided and reflected until it paints the sky twice. When you see a double rainbow, you are witnessing sunlight dancing through countless droplets, painting parallel arcs that curve through both physics and poetry. Moonbows are rainbows made by moonlight. At night, when the moon is bright and the air is misty, a rare and subtle wonder can appear among. Just like a regular rainbow, it is formed by light refracting through droplets of water. But instead of sunlight, the moon provides the glow. Because moonlight is far dimmer than sunlight. Moonbows are often white to the eye, though cameras can reveal faint bands of color. They tend to appear opposite the moon, arching gently through the darkness. To witness one is to see the night sky transformed into a quiet symphony of silver and mist. Moonbows remind us that light never truly rests. Even in darkness, it finds ways to create beauty. Where day brings bold color, night offers its own softer miracles. Reflections of light slowed to a whisper. Mirages make water appear where none exists. On hot days, travelers across deserts or long highways sometimes see shimmering pools of water ahead that vanish as they approach. These are mirages, illusions created by layers of air at different temperatures. When hot air near the ground bends light from the sky, it creates reflections that look like water or distant lakes. The light is real, but the image is falser, trick of temperature and perception. In cold regions, a similar effect can make distant objects seem to float above the horizon, called a superior mirage. Ships may appear to hover in the air, or mountains rise where none exist. Mirages remind us that the atmosphere is not a perfect window, but a living lens, bending light into shapes that play with our senses. What we see is not always what is there. Even the air itself can paint illusions. Halos and sundogs frame the sun in circles of light. Sometimes, when high, icy clouds drift across the sky, faint circles or bright spots of light appear around the sun or moon. These are halos and sundogs, formed when sunlight refracts through hexagonal ice crystals suspended high in the atmosphere. A halo appears as a glowing ring surrounding the sun, while sundogs, also called peheli, shine as twin bright spots on either side, often tinged with rainbow hues. They follow the sun's path like loyal companions, shifting as it rises and sets. Pilots, mountaineers, and Arctic explorers often see them where ice crystals are common. The sight of a halo can feel otherworldly, as though the sky has donned a luminous crown. They are among the most ethereal gifts of cold weather geometry and light, combining to turn ordinary sunlight into something sacred. Ball lightning can glow inside rooms. Among the rarest and strangest weather phenomena is ball lightning, a glowing sphere that sometimes appears during thunderstorms. Witnesses describe balls of light drifting through the air, bouncing off walls, or floating silently before vanishing in a flash or with a pop. Scientists are still uncertain about how it forms, though theories include plasma trapped in magnetic fields or vaporized silicon reacting with oxygen. Ball lightning has been reported for centuries, sometimes even appearing inside houses through open windows. Though it may last only seconds, its appearance is so bizarre and mesmerizing that it feels supernatural. Ball lightning blurs the line between myth and science, a wandering light born from storm and electricity, glowing briefly in defiance of explanation. St. Elmo's fire turns ship masts and airplane wings blue. During powerful storms, sailors once saw eerie blue flames dancing on the tips of their ship masts and believed them to be spirits. In truth, St. Elmo's fire is a natural electrical phenomenon caused by strong atmospheric electric fields. When the air becomes highly charged, it ionizes around sharp objects like masts, church spires, or airplane wings, creating a ghostly glow. The light is usually blue or violet, flickering silently in the stormy air. To those who once braved the open seas, this glow was seen as a good omen, a sign of protection from Saint Erasmus, the patron saint of sailors. Today, we understand it as electricity made visible, the atmosphere crackling just before lightning strikes. It remains one of nature's most beautiful warnings, a spectral flame that dances on the edge between calm and storm. Sprites and blue jets flash above thunderstorms, while lightning bolts lash downward toward the ground. Other luminous events leap upward toward space. Sprites and blue jets are flashes of light that occur high above thunderstorms, far above the clouds we see from below. Sprites appear as red, branching tendrils stretching upward, while blue jets shoot narrow beams into the stratosphere. They were once thought to be myths, but modern cameras have captured them from aircraft and even the International Space Station. These lights last only a fraction of a second, but they reveal that storms reach higher than we ever imagined. They are lightning's hidden counterpart, connecting weather on Earth to the edge of space. To see them is to witness the atmosphere's secret fireworks, bursting silently where sky meets cosmos. Weather can sing through the wind. If you have ever heard a low, mournful hum echoing across a mountain pass or between tall buildings, you have heard the voice of the wind. As it rushes through narrow gaps or around sharp edges, it vibrates the air, creating natural music. Power lines, fences, and even sand dunes can all become instruments, resonating with tones that rise and fall as the wind changes speed. In the Antarctic, scientists have recorded the Ross ice shelf singing, its surface vibrating in haunting melodies created by moving air. The Earth, it turns out, is never silent. The wind hums through rocks, deserts, and oceans, carrying its songs from place to place. Some call these voices eerie, others soothing, but they are all part of the living language of weather, the sound of air itself, whispering through the world. Tornadoes can make the air roar like a train. When people describe tornadoes, they often compare their sound to a freight train thundering by. This is no exaggeration. The rotating column of air, filled with debris and pressure changes, creates a deep, continuous roar that grows louder as the tornado approaches. Scientists studying recordings have found that each tornado produces its own unique acoustic signature, depending on its shape and strength. For those who have survived them, the sound is unforgettably a wall of noise that seems to fill the world. Before modern warning systems, that sound was often the first and only signal to seek shelter. It is weather made audible, power transformed into vibration. A reminder that even air can growl when set into violent motion. Some deserts sing with voices of sand. In certain remote deserts, dunes hum, boom, or sing when disturbed. As sand slides down the slopes, it vibrates in unison, producing a deep, resonant sound that can last for several seconds. Marco Polo once wrote of hearing spirits in the desert, not realizing he was hearing the voice of sand itself. The sound depends on the size and dryness of the grains, as well as the slope of the dune. It can be as loud as thunder, rolling across miles of desert like a giant's breath. These singing sands are rare, found in places such as the Gobi Desert, Death Valley, and parts of Chile and Oman. When you stand among them, you can feel the dunes vibrating beneath your feet. The landscape itself alive and singing a song composed by wind, sand, and gravity. Temperature inversions can trap sound near the ground. On cold, calm nights, a layer of warm air can settle above cooler air near the surface, creating what is known as a temperature inversion. This phenomenon doesn't just affect air quality, also changes the way sound travels. Normally, sound waves spread upward and dissipate, but during an inversion, they bend back toward the ground, carrying noises farther than usual. A barking dog, a train, or distant thunder may seem unnaturally loud or close. In valleys or over still lakes, The effect can make ordinary sounds echo hauntingly through the night. To our ears, it feels as though the world has grown smaller, sounds wrapping around us instead of fading away. The weather, without changing its appearance, reshapes how we hear, turning the atmosphere into a giant acoustic chamber. Lightning can travel from one cloud to another for miles. We usually think of lightning as striking from a cloud to the ground, but most lightning never touches the earth at all. Many bolts leap from one cloud to another, sometimes spanning distances of dozens or even hundreds of miles. In 2020, a record-breaking lightning bolt stretched across the sky over Brazil and Argentina, measuring more than 700 kilometers from end to end. That is farther than the distance between London and Berlin. These immense bolts flash silently from the ground's perspective, illuminating vast stretches of sky. They reveal the hidden architecture of storms, the way electric charges flow through towering cloud systems, connected by invisible filaments. Lightning that long is almost beyond imagination, a river of electricity connecting storms across entire regions, glowing and vanishing in the blink of an eye. The smell before a storm comes from electricity. Long before the first raindrops fall, there is a certain scent that tells us a storm is near, a clean, metallic fragrance carried by the wind. That smell comes from ozone, a molecule made of 3 oxygen atoms. As lightning and electric charges ripple through the atmosphere, they split ordinary oxygen molecules apart, allowing them to recombine as ozone. Our noses are remarkably sensitive to it, detecting even tiny concentrations. The scent mingles with moisture and dust, creating the distinct storm smell many people love. It is the smell of the sky preparing to break open, the signature of energy building in the air. Every thunderstorm writes its presence first in scent, then in light and sound, a full symphony of the senses. Orchestrated by weather itself, air pressure changes can make your ears pop. When a storm approaches, or when we climb to higher altitudes, the air around us changes pressure. Our ears are sensitive to these shifts, and when the pressure inside and outside the eardrum become uneven, we feel that familiar pop. The same thing happens during takeoff in airplanes or when driving up a mountain road. In nature, sudden drops in pressure often signal incoming weatherstorm fronts, high winds, or even hurricanes. Many animals can sense these changes more acutely than humans. Birds may fly lower, fish swim deeper, and dogs become restless. The atmosphere, constantly in motion, presses and releases around us like an invisible tide. Those little ear pops are tiny messages from the sky, subtle reminders that weather is always pressing closer than we realize. The color of the sky can warn of danger. We often admire sunsets for their fiery colors, but sometimes those hues tell us more than beauty. They reveal what the atmosphere is doing. A greenish tint before a thunderstorm can mean hail or tornadoes are forming, as sunlight filters through dense moisture in the clouds. A red sunrise can warn of incoming storms from the west. Captured in the old saying, "Red sky in morning," sailors take warning. Dust, smoke, and pollution can also alter sky color, scattering light differently. To early sailors and farmers, reading the sky was both art and survival, a way of predicting weather without instruments. Even today, the sky remains a storyteller, its colors shifting to reflect the mood of the air. Look up, and you can often read tomorrow written in the light. Rain can fall in colors other than clear. Though we usually imagine rain as transparent, under certain conditions it can appear red, yellow, or even black. When winds carry dust or ash high into the atmosphere, Raindrops collect those particles as they fall. In parts of Europe, people sometimes witness blood rain, tinted red by dust blown from the Sahara Desert. After volcanic eruptions, rain may fall grey or black, mixed with fine ash. In pollen-heavy seasons, rain can appear golden, leaving a thin yellow film on surfaces. None of this is magic, just chemistry and motion, but to those who see it, the effect is uncanny. The sky seems to weep with color, painting the earth in tones borrowed from distant lands. Every drop becomes a tiny canvas, proof that even the simplest weather can carry traces of the planet's farthest corners. Some storms rain animals from the sky. Throughout history, people have reported frogs, fish, and even small crustaceans falling from the clouds. Though it sounds mythical, such events can happen. Waterspouts and strong updrafts sometimes lift small animals from ponds or seas, carrying them high into storm clouds. When the winds calm, the creatures fall back to earth with the rain, often startling those below. In Honduras, a yearly event known as Lluvia de Peces, the rain of fish has been recorded for decades. Scientists believe local storms may indeed lift fish from nearby rivers, depositing them miles away. Though rare animal rains are reminders of how powerful the atmosphere can be, strong enough to gather life from the water and scatter it through the sky. What falls from above is not always just rain. Sometimes it is a fleeting shower of wonder. Weather has shaped human history again and again. Battles, migrations, and even the rise and fall of civilizations have been steered by the moods of the sky. In ancient Egypt, the flooding of the Nile was tied to seasonal rains far to the south, dictating harvests and survival. The Mongol invasions of Japan were halted by typhoons known as the divine winds, or kamikaze. Napoleon's army was defeated in part by the brutal Russian winter, and in modern times, droughts and hurricanes still change the course of nations. Weather is both ally and adversary, an invisible participant in human history. While we build machines and cities to resist it, we remain deeply vulnerable to its whims. Every empire has felt the weight of weather's hand, whether through a failed harvest, a flood, or a storm that arrived just one day too soon. Clouds can weigh billions of tons, yet float effortlessly. It seems impossible that something so heavy could hang in the sky. Yet clouds stay aloft, because the air around them is also in motion. Rising warm air supports their weight, and because their water droplets are tiny, just microns across, they fall so slowly that upward currents easily hold them. A large thundercloud can contain over 1 billion tons of water, enough to fill an entire lake. But suspended as vapor and mist, it drifts gently, glowing white in the sunlight. When those droplets combine and grow heavier, gravity wins and rain begins. The balance between rising air and falling water is delicate, sustained by constant movement. To think that the sky above you carries oceans in waiting is both humbling and awe-inspiring, a reminder that even the calmest day hides a sea of invisible motion. There are clouds that never touch the earth. Most clouds form in the lower atmosphere, but some belong to realms far above. Noctilucent clouds, for instance, drift at the edge of space around 80 kilometers high. They are made of tiny ice crystals that catch sunlight long after the sun has set, glowing electric blue against the night. Seen only from high latitudes, they are among the rarest and most delicate of clouds. Other high-altitude forms, like nacreous or mother-of-pearl clouds, shimmer in pastel colors when the sun is low. They appear so ethereal they seem painted onto the heavens. These clouds are fragile creations, forming in air thinner than a vacuum chamber. Watching them feels like glimpsing another layer of the world, a veil between Earth and space where light plays its final games before fading into the stars. Some clouds form perfect lenticular shapes like UFOs. Over mountains, the air can rise, cool, and condense in rhythmic waves, forming lens-shaped clouds stacked like pancakes. These are lenticular clouds, smooth and symmetrical, often mistaken for flying saucers. Their stillness adds to the illusion, while other clouds drift. Lenticular clouds hover motionless above peaks, continuously forming and dissolving as air flows through them. Pilots avoid them because the air currents that create them, called mountain waves, can be dangerously turbulent. Yet from the ground, they are breathtaking, glowing pink and orange at sunset, their contours sharp as sculpture. It is easy to see why so many UFO sightings trace back to these serene shapes. In truth, they are not alien visitors, but the sky itself experimenting with form and balance, carving perfect ovals out of air and moisture. Clouds can cast shadows on other clouds. When sunlight filters through breaks in the sky, beams of light and shadow may appear, shafts radiating from the sun like divine fingers. These are crepuscular rays, formed when clouds block some sunlight while letting other beams through. The light scatters on dust and moisture, revealing the paths of the sun's rays. Sometimes, these shadows stretch across other clouds, dark streaks against glowing white. At sunrise or sunset, when the light is low and warm, they can seem almost solid, connecting the heavens to the horizon, though easily overlooked. These patterns reveal the three-dimensional nature of clouds and sunlight, a dance of light and shadow written across the sky. Every sunset is unique because no two skies ever share the same geometry. The next time you see sunbeams breaking through clouds, you're watching light made visible by the breath of weather itself.